So again, we're going to begin with almost all of our vocabulary. I've got it kind of, even though it scrolls out of the second page. Before we get into any examples, we're going to have to get all these definitions taken care of. Now, I'm going to tell you this, and a lot of these definitions, you're probably going to be like, I already know what these mean, blah, 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 that's fine. Today we're going to do section 1.8, and tomorrow we're jumping into section 8.1. We're going to have a lot of vocabulary in there that you do not know, all right? So here's what I will tell you about the second semester of Algebra Foundations. It is pretty much the first semester of Algebra 1 on a basic level, okay? And then when we get to Algebra 1, you take this up a level. So like what we would call our level 3 and level 4s become their level 1s. So you kind of just build it more and more as we get going. So when I started my new semester today with my Algebra 1 students, I pretty much told them we are now leading pre-algebra, because that's really all we've done for about 3 months, is we reviewed on a deeper level everything that we learned in the second semester of this particular course. Okay? So we're going to keep that in mind. There's going to be a lot of stuff here that is brand new to us, even if today seems like it's a lot of review for us. All right. So, again, I realize this is going to be the most energetic here, but like we've just got to grind through these vocabulary words and know these as we get going. Okay? So, the coordinate plane, here's our definition. This is the intersection of a horizontal number line which we refer to as the x-axis, and a vertical number line which we refer to as the x-axis. Intersection of a horizontal number line and a vertical number line. All right. Someone remind us, what is a horizontal number line look like? What would that look like? Anyone remember? Kane? Left to right. Okay. Kane, do you have any way that you remember that? Horizon. Yep, exactly. Just like on the horizon, the horizontal means we're talking about left to right. So when it says it's the intersection of a horizontal number line. So I could take a number line, which we talked about in unit number 3 for us. We talked about solving and graphing inequalities. So on a number line, we'd have 0, 1, 2, 3, 4, 5. And then that number line keeps going on forever in that direction. And then over here, we've got -1, -2, -3, -4, -5 here, -6, -7, -8, and that continues on in that direction. So that's our horizontal number line, okay? This is what we refer to as our x-axis, okay? Because we're going to take this one and we're going to combine it with another. So if that's my horizontal number line, now we're going to take a vertical number line and intersect it with this one. Now, this number line has our negative numbers down here. So here's -5, -6, -7, -8. And again, it keeps going on forever there. And our positive numbers are up here on the top. So this is our y-axis. Okay? That's all the coordinate plane is. It's the intersection of a horizontal number line with a vertical number line. All right? So, back kind of in middle school and everything else, you probably, and at some point, I'm sure you started to discuss this, because this technically is like, when I look at the standards, not this standard, we're not tested on this standard, but this is actually something taught in 6th grade. That's why today is just a lot of review with this. Okay? But in 6th grade, you were started to introduce to this two-dimensional world. because everything before that was one-dimensional. Now, not only do we have a left and a right, we also have an up and a down, okay? And then when you get really advanced in high school, you'll have the third dimension. There's actually a third axis. Most people aren't aware of it. It's called the z-axis. The z-axis is a number line that comes out this way, okay? So like if you're in computer graphics or anything, you have to deal with things that deal with three axes. That's what gives you your three-dimensional figure. You don't just draw stuff two-dimensional, okay? So we're going to begin today, though, just kind of talking about the basics of our coordinate plane here, all right? Now, the next two, we've kind of already defined them, but we need to give the formal definitions of this. Our x-axis, all right? This is the horizontal number line. In a coordinate plane. And it's a geometry term, but when we're talking about a coordinate plane, we're talking about a two-dimensional surface that continues in all four directions forever. So like in geometry, one of the very first things that we define is what is a plane. And I tell them to think of a whiteboard that just continues forever and ever and ever. Okay? So when we talk about the coordinate plane, that continues in all four directions without it. All right? Then, of course, we know that if the x-axis is the horizontal number line, the y-axis is the vertical. Okay, so our y-axis is the vertical number line in a coordinate plane. And again, I have them labeled here. These aren't going to be labeled on your assessments. You need to know that the x-axis is my left and right one, and my y-axis is my up and down. That's my vertical one. All right. Now I got two more vocabulary terms, and then I'm going to try and bring everything together. I purposely put a picture of the coordinate plane here so we can take all of our vocabulary terms that we have and bring them together in one big idea. All right. So the next is the origins. Anyone know what the origin is? Okay, it's 0, 0 if we want to think about it as an ordered pair, but it's the center of the coordinate plane. Okay, here's how we're going to define it. It is the point 0, 0, as Clinton just pointed out. Okay, where the x-axis and y-axis meet in the coordinate plane. Why does everyone think that they call it the origin? Any thoughts? When you think about graphing points, it might help you think about why they call it the origin. Miles?
It's the point where both the lines connect.
Okay. It is the point where both the lines come from, but since they're lines, they actually are going on forever, right? But any other ideas on why? Why do you think they call it the origin? What's origin mean to you? What's that?
The
Place
place where they started.
where you started. Okay, and when it comes to graphing on the coordinate plane, which is what we're going to be doing today, you always need to begin or start at the origin. You don't just randomly start wherever you want. You begin at the origin, and then you talk about moving left and right and up and down and everything else. All right, The last one that all ties in with this here is this idea of a quadrant. Okay? So this is one of the four regions that a coordinate plane is divided into by the x-axis and y-axis. One of the four regions that the coordinate plane is divided into by the x-axis and the y-axis. All right, so here's what I want to do. I want to take almost all of our vocabulary terms and I want to start to put them on this picture. So that way we can see how all of these kind of relate to one another. Now, I didn't just grab any random picture. I specifically grabbed a picture because we're going to do a lot of graphing starting today and continuing the rest of this unit. Okay? I'm going to give you graph paper for all of these problems. This is what your graph paper is going to consist of. Okay, graphs that look like this. When they show up in your assessment, most of the time, they're going to look like this. So here's a couple things that I want to point out right away. Okay, we've got a number line right through here. All right, but I have only labeled my even numbers. So here's one thing that you got to pay attention to. What does each one of the lines on that coordinate plane count as you look at it? Like if I move one line, how far am I moving on the x-axis? I'm moving just one value. Now some people might be, well, why did you label every other? Because if I were to write the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this would be a garbled up mess right here. Okay? But by labeling every other one of these as 2, 4, 6, 8, and 10, that's implying that this is 1, 3, 5, 7, and 9. So just so you kind of get used to the scales on that, okay? Because there's times from time to time, ladies and gentlemen, we're going to want to change that. But on our graph, the way that I've given this to you, each one of those counts. Each one of those vertical and horizontal lines counts as one unit on the x and the y-axis. Okay? Now, the whole thing in general is a coordinate plane. So I'm not going to label anything with that. That is what it is. Okay? Again, it continues up, down, left, and right forever and ever and ever. Okay? Our next definition, though, we talked about the x-axis. So we're going to go ahead and label that here. The x-axis, remember, is the horizontal axis. And as Kane reminded us, horizontal and horizon are how we can put those two together. So I'm going to go ahead and just label that real quickly as that is my x-axis. Our next definition says the y-axis. The y-axis, remember, is the vertical line that goes between or that creates the coordinate plane. So this one right here is our y-axis. Okay? After we define the x and the y-axis, the next definition that we had was the origin. And we define the origin as the point of intersection where the x-axis and y-axis meet. That is right here. So this point right here is the origin. Anytime that we go to graph something, that's where we're always going to begin, is at the origin. Now, the last part is our quadrants. How many quadrants did we say that this is broken into? 4. Okay? Each quadrant has its own name, and they did not get real original when they named these. They just call them quadrant 1, quadrant 2, quadrant 3, and quadrant 4. But here's the tricky part. And back in my day, a long, long time ago, when I was learning this, this was a lot more common. Yes, that was a long, long time ago. Okay? No comments, Cole. So, we use Roman numerals, and we're going to still expect you to use Roman numerals. I'm going to venture to say that most of you probably don't know anything about Roman numerals. Do any of you know anything about Roman numerals? Perfect. Well, I'm telling you a couple of things here. One thing you know about Roman numerals.
I got like being like 5 and like I don't know so I know how to read them somewhat.
Okay, you know how to kind of somewhat read them, but he is correct that the Roman numeral 5 is a V. So if you're saying, what do you mean by that? If I were to give you this number as a Roman numeral, that does mean, in fact, 5. Any Star Wars fans, you should at least know through 10, right?
Yeah.
Because that's how they number all their Star Wars. Okay? But if you're a Super Bowl fan, you should know through 54. Because that's how they always name the Super Bowls, right? They started with Roman numerals. Okay, does anybody else know anything else about Roman numerals? That's a 5.
Isn't like the 2 lines like 2?
Okay, so technically, anytime that I have a line like this, okay, so just like an I, this is 1. And if I add another line in here, that now becomes a 2. And if I add another line in there, this now becomes a 3. Okay, that's the way Roman numerals work. It seems pretty easy, but there is a little math involved in it. Does anybody else know anything else about Roman numerals? Miles?
X equals 10.
Okay, X does equal 10. Any others? I don't know this one because it was a big deal when Super Bowl 40 was around. L is 50. It is a little confusing, but I still remember when that Super Bowl XL came out and it was Super Bowl 40. That was the big deal. Anyone else know anything about Roman numerals? Because here's the math part that goes into it, okay? And I know this might seem completely off topic, but we don't, when we use Roman numerals, as Jacinthia pointed out, every one of these, when we go to start adding a line, just counts as a 1. But I'll tell you this, we never go above 3 lines, ever, 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 ever. Do we use more than 3 lines? So you say, well, if we never get more than 3 lines, how in the world do we talk about 4? Okay? So here's what we need to know. Roman numerals, if I want to start talking about 4 or 6 or 7 or 8 or 9 or whatever, I'm going to actually have to start to do math problem. Okay? So if I were to give you an example of this, I'm going to do these two that look almost identical to one another, but they mean different things. Okay? Those two right there. All right? Now, here's where it gets a little confusing, but I'm not going to test you on this other than the fact that you need to know what 4 is. Okay. Who told me what X stood for? 10. Okay? This stands for 1. So here's the way a Roman numeral works. When the bigger number is first, followed by a smaller number, you're going to take these two and add them together, and this is the 11. Okay? I got a 10 first, followed by a 1 second, that gives me 11. But, what's this here? 1, what's this here?
It's 9.
This actually now becomes a 9. Because instead of adding these two together, I take 10 and I subtract the number that's in front. So this actually becomes a 9. So we'll never use 4 straight lines. Because if I want to get to 4, okay, then I actually just bump myself up to the next multiple of 10 and I subtract a 1 from it. What in the world am I talking about here? Okay? Back to this idea. Quadrants, there's 4 of them. We use Roman numerals to describe each one of them's location. Does anyone know where quadrant number 1's at? Top, well, there's 2 tops. Top right, okay? So this right here is quadrant number 1. And again, with Roman numerals, it's just like an I. Okay, I'd like you to write that in there, ladies and gentlemen. You will be tested on this. Okay? Now, if we know where quadrant number 1 is, that really means that logically there's probably 1 of 2 spots for quadrant number 2. Who remembers what direction we go?
Don't we go to as a quadrant 2 on the top left?
It is. We go counterclockwise. Okay? So over here is quadrant number 2. And then we just continue to go counterclockwise. So down here is quadrant number 3. Now we get to quadrant number 4, but I told you we're now going to use 4 straight lines. So, quadrant number 4 is, we're going to think about it like this. Okay, except we don't want a 10 here, we want a 5 here. So what do we say a 5 was? A V. So this is 1 followed by a 5. That tells me that that is quadrant number 4.
In a fold.
Yeah, it should be a full V, yeah. Sorry. Gosh, being picky today, Delaney. There you go. There's quadrant number 4. Okay, one of the things on your homework tonight is they're going to ask you to describe the location of an ordered pair. Okay? There's actually going to be 7 ways to describe the location. This is 4 of them. Okay, quadrant 1, quadrant 2, quadrant 3, quadrant 4. You might say, well, what are my other 3? Well, sometimes I'm going to have a point right here. Where's that point at? Well, it's not in quadrant number 1, is it? And it's not in quadrant number 4, so it's located on the x-axis. That's another location. Sometimes I'm going to have a point right here, right in between quadrant 1 and quadrant 2. Well, where's that located? On the y-axis. And sometimes I'm going to have a point right here, and where do we call that? The origin. There's my 7 locations. I've got 4 quadrants, I've got 2 axes, and I also have the origin. All right, so let's flip it over and keep going. Like I said, a lot of vocab with this today. All right, so an ordered pair is this. It is a pair of numbers okay, ordered pairs will always be listed in parentheses. You must have them in parentheses and a comma to separate them. So it is a pair of numbers. We're going to call them an X and a Y that can be used to represent a point in the coordinate plane. A pair of numbers, so there'll be an X comma Y that can be used to represent a point in the coordinate plane. Okay? Now, this ordered pair is made up of what we call 2 coordinates. The X coordinate and the Y coordinate. Okay, our last 2 definitions today. So the X coordinate is the first number of an ordered pair. Which I think most of us could probably write the definition for the third one then. The Y coordinate is the second number. Of an ordered pair. All right, and so remember, these are number lines. So the first coordinate's going to tell you on the x-axis where to travel at on that number line. Your second coordinate, which is your y-coordinate, is going to tell you where to travel up and down on the y-axis for your second point. And then that's going to be able to give you the location of a particular point. So really two different types of problems we're going to ask you to do today. And again, I'm hoping a lot of this is review. I'm not teaching it like it's new because we're getting through pretty fast here. Okay? I'm going to ask you, here's a graph. Tell me what the ordered pairs are. And I'm also going to flip it around and say, here's some ordered pairs. Now I need you to be able to graph them. Okay? Because for us to be able to talk about what is a function, what is a relation, and everything else, we need to be able to graph things very, very well. All right? And I don't want these to be one of the topics where people are like, kind of, you remember this? We're spending today just to refresh because we got to get really good at this for what we need moving on. All right, so example number 1. Give the coordinates of each of the following points. So I'm asking for each of these to be written as an ordered pair. 2 things to remember, and I am picky when it comes to your assessments. Ordered pairs must be listed in parentheses, and they must have a comma used to separate those 2 numbers. So, where do we always begin when we talk about a graph? We start on the origin. Then to find the first number, we're talking about moving on the x-axis. To find our second number, we're talking about moving on the y-axis. So if I begin at the origin, what is the x value I need to start to get to A? I need 2. I need to go 2 units to the right. That is a positive 2. Okay? Now, if I move 2 units to the right, where do I still need to go to get to point A? Down 3 units. And if I'm traveling down, that is a negative number on the y-axis. So I'm traveling down 3 units. So point A should be listed as the ordered pair of 2, negative 3. Okay? Now, again, if I want to list point B, where do I begin talking about this graph? At the origin. Okay? So where do I travel to get to B? 3 units left, which according to this number line means I've actually gone where? To negative 3. And then what? Up 2 units, which tells me I've traveled a positive 2 on the y-axis. So this is the ordered pair of negative 3, 2. All right, if you haven't already, go ahead and do the last 3, write those as ordered pairs for me. Make sure you have parentheses around those. All right, Claire, what'd you get for point C? Negative 3, negative 4, perfect. All right, Bryce, what do you have for point D?
Over 3, up 3.
3, 3, that is perfect. All right, Abby, what do you got for point E?
I got
0, 0, because point E is the origin. So I've traveled 0 units to the left or right, traveled 0 units up or down. There's my ordered pair of 0, 0. All right, now the next example, all we're doing is flipping the roles, but I did add an extra piece. You're going to graph it, label it. So draw a point and label it as A, B, C, D, E, or F, whichever point you're graphing, but then also describe the location. And remember, when it comes to describing the location, there are 7 options. Quadrant 1, quadrant 2, quadrant 3, quadrant 4, the x-axis, the y-axis, or the origin. All right. Quan, can you tell me, how do I graph point A? So where do I always begin? Well, I always, like here or where? At the origin. Okay, from the origin, where do I go? Over 1, which way? Right 1 and down 3 units. Okay, plot a point right there and label it. Okay, label it with the letter that I used in that problem. That is point A. Okay, Hayden, we got to describe its location. Where is point A located? This is in quadrant number 4. All right, Chloe H, tell me how I'm going to graph point B. Begin at the origin, and then what? Over 2, left 2, and down 2. Okay? Plot your point, label it as point B. Delaney, where is point B located at? Quadrant 3. All right, now I'll be honest, C and E are the two that are by far the most mixed up. Okay, when I start giving zeros as an X or a Y value, that really throws people off. You got to make sure that you're good at graphing these. Okay, Kane, how do I graph point C?
To the left 3.
From where?
And
From the origin, left 3, and then where? Nowhere, exactly. Okay, this should be point C right here. Okay, there will be a lot of students that will end up graphing that one down here. But that first value is the X value. That tells me left or right. The second one tells me the up and down. Okay, Megan, can you tell me where is point C located? It's not in the quadrant because it's in the middle of them. So what do we call that? Flip it back over to the front page. Remember all the labels that we had. We had quadrant 1, 2, 3, 4. What did we call it if it was on this line? Not the origin, because the origin's right there. Cynthia, help her out. Where's this at? It's on the x-axis. Okay, remember that's one of the 7 possible locations. We got quadrant 1, 2, 3, 4, the x-axis, the y-axis, and the origin. We want to use all of those as part of my descriptors. All right, Chloe K, tell me how to graph 3, 5. Right 3 and then what? Down 5? Up 5. All right, here is point D. Quentin, location is what? Quadrant 1. All right, Serena, tell me how I graph point E. Start where though? Okay, and just down 4, that's it? What's that? Okay, and then that's it, all right? Okay, so here is point E. Okay, my 0 was my X value, so that was the no left and no right part of it. The negative 4 told me to go down 4. Okay, Miles, what's my location of point E?
Y-axis.
This is on the y-axis. Evan, tell me how I'm going to graph point F. There we go. To the right 4 and down 2. Here is point F. All right, and Roland, give me my location.
Quadrant 4.
Quadrant 4. All right, does that make sense? Okay, one more quick thing here. Flip it over back over to the front page now that we've graphed these. Something that I'm going to ask you to be able to do, okay, is coming back to the coordinate plane here. We've talked a lot about ordered pairs and everything else now that we've seen this. I want somebody to see if they can come up with a generic explanation, or not generic, but just general explanation. How do I know if something is going to be in quadrant number 1 when I look at the ordered pair? How can you tell me it's got to be in quadrant number 1? All right, the X value is positive and the Y value is positive. So here we talk about these both being positive, so I talk about that as a plus area. Okay, how am I knowing if I'm going to end up in quadrant number 2? Caitlin? Okay, which one though?
The first one's negative and the second one's positive.
All right, if I'm going to end up in quadrant number 2, my first one is negative, my second one is positive. Okay? What about quadrant 3? Both of them are going to be negative. In order for me to be in quadrant number 3, both of these need to be negative. How am I going to end up in quadrant number 4? Caitlin?
The first one's positive and the second one's negative.
The first one's positive and the second one is negative. Can anyone tell me, how do I end up on that line?
This is like 0 and another number.
So 0 comma some number?
Yeah.
Nope.
If the y part is 0.
Yes. So we've got to flip it around. There is a 0 here, but the 0 must be the y value. What about the x value? It doesn't matter. It can be positive or it can be negative. But if the y value is 0, you're going to be stuck on this axis. This is a big idea that we're going to talk about at the end of the unit here. Okay? What about if I'm going to end up here? Caitlin?
The 0 is the first spot.
0 is the first spot, and my second one is positive or negative. Again, it doesn't matter. Okay, but if I've got a 0 as my x-coordinate, I'm going to actually be on the y-axis. All right? Mrs. McClure, do you mind grabbing the graph paper? It should be right up there, I think, in one of those 2 bins. Homework for tonight is going to be page 49. Numbers 1 through 6 and 8 through 26. All right? Now, if you don't have enough graphs, then all I would tell you is use the same one over again. Okay? So if you need to do, like if it says, hey, graph these 5 points, maybe use one graph for all 5 of those and just label them. Here's 21, here's 22, here's 23, so on and so forth. And again, the graph paper is 3-hole punched, so you should just be able to keep it right into that binder with all of your other homework assignments and everything else.